Hello students, welcome you all to the video lecture on chapter number 9, Mensuration, exercise 9.2, question number 5. The question is, Daniel is painting the walls and ceiling of a cuboidal hall with length, breadth, height of 15 meter, 10 meter, 7 meter respectively. Respectively they have given, meaning that these measurements are in sequence. That is, they have given that length is given by 15 meter and breadth is given by 10 meter and then height is given by 7 meter. From each can of paint, 100 meter square of area is painted. How many cans of paint will she need to paint the room? So they have given that one can of a paint can paint the area of 100 meter square. So if it is so, first we need to find out the surface area for the given cuboidal hall except the bottom of the cuboid, and then we need to find out how many number of cans we need to use in order to paint that particular room. So ceiling means here the top surface of a cuboid. So for these things, first let us consider a cuboid. So let us consider a cuboid where I have totally 6 faces. So here this is the front face, and then we have back face, and then top face, bottom, and then 2 side faces. Okay, so these are all the 2 side faces, and then top and then bottom, and then this is front, this is back side. So totally we have 6 sides. So front face and the back face are affected by the measurements like length and height. So this one is length, this one is height, this one is breadth. So whenever we find out the area of the front face, so area is calculated by length into height. Why? Because this is having length and this is having the height. Whenever we want to find out the area of a side face is having the breadth and then height. So this is the breadth and then height. So for the side face, the area is given by breadth into height. And then for top face, so this one is length and this one is breadth. So for the top face and the bottom face, the area is calculated by length into breadth. So these are all the things first you have to understood in order to find out the area of different shapes. So here it is a cuboid. So what I am saying, for the front face, in order to calculate the area, we have to consider the length and then height. For the side face, we have to consider the breadth and then the height. And top face, we have to consider the length and then the breadth. So the total surface area here in this problem, it is given by, we need to consider the 4 walls of a cuboid. So what are the 4 walls, outer walls? It is area of the side wall 1, area of a side wall 2, and the area of a front face, area of a front face, that is front wall, area of the back wall. These are all the 4 walls of a room. And then top ceiling they have given, and ceiling of a cuboidal hall. Ceiling is nothing but a top surface, right? So area of top wall. So these are all the things we need to cover in order to paint. So side wall 1, what are all the measurements it is affected? It is breadth into height. What about the side wall 2? That is also breadth into height. What about the front face? It is length into height. What about the back face? It is again length into height. What about the top wall? It is length into breadth. According to the discussion, we have written the formulas as this. Okay. So either you can substitute all the values here directly, or you can simplify this also, you can substitute your values. In the previous problem, that is question number 4, we have simplified this 4 walls formula as what? 2 into h into L plus B. Okay, instead of writing this big 4 formulas, we have simplified that as 2h into L plus B. Directly you can use that formula, or you can directly substitute here. So previous problem I have used this formula, now I am going to substitute directly. Okay. So if you want, you can refer the previous problem. So breadth into height. What is breadth into height? It is 10 into 7. Again breadth into height, it is 10 into 7. Length into height. What is length into height? It is 15 into 7. Again length into height, it is 15 into 7. Length into breadth, it is 15 into 10. Okay. So 10 into 7, it is 70. Again 10 into 7, it is 70. 7 5s are 35 and carry 3. 7 1s are 1. 7 1s are 7. 7 plus 3, it is 10. So again 15 into 7, it is 105. And then 15 into 10, it is what? 15, and then end 0. You can add here 150. Okay. So add all these values. So what are all the values? 70 plus 70, it is 140, because 7 plus 7, 14, and then 105, again 105 and 150. So just add all these values. So 5 plus 5, it is 10, 1, 5 plus 4 plus 1, it is 10, and then 5. So totally the value, it is 500. 500. What about the measurement unit? Here everything it is in meter. So meter into meter, it is meter square. So total surface area is given by 500 meter square. And then coming to the question, what they are asking, how many cans of paint will she need to paint the room? If each can is able to paint 100 meter square. Okay, so total surface area is 500 meter square, but each can, it can paint only 100 meter square. We need to find out the number of cans. So the number of can is given by total area, total surface area divided by area painted by 1 can. So if you divide these two values, total area and area painted by 1 can, we can find out what? The number of cans. What is the total surface area? It is 500 meter square. What is the area painted by 1 can? It is 100 meter square. So meter square cancel, 0, 0, 0, 0, get cancel. The total value, it is nothing but just 5. So the number of cans, it is nothing but 5 cans of paint is required in order to paint the total surface area of a given room except your bottom surface, right? Thank you. Thanks for watching.